already there, but based on this energy density, it needs little more improvement. Currently, the energy density wise very less, but the duty cycle wise is one of these chemistries has got a very high duty cycle. So, in future, we'll be using this for mostly EV and also for energy storage application. So as I mentioned already, why LFP is commonly used for industrial application? Because of the safety. Main reason is safety. Compared to other chemistries, lithium iron phosphate is more safer. That's why we mostly switch over to LFP chemistry. So when we make this lithium, which is similar to that, so cathode material and anode material, and there will be a separator, and it's rolled and encapsulated in the cylindrical form of containers. And you get anode and positive and negative taps. So this is how this is made. This is a steel container, so there should be insulator in the top. So this is one form of lithium ion cell. This is called cylindrical form. Then this is another form, now commonly used form factor we call it. This is called prismatic cells. This will look like a box, just a cylinder, rectangle box. Capacity wise, this will be on higher on capacity. It will start from 50 Ah, each cell is 50 Ah, and 105 Ah, 230, 280, 304. Now there is upcoming, I'll show you the picture, the 1178 Ah cells are already available. So to make a 10 kilowatt hour battery, you just need a very small space. So you carry a 10 kilowatt. So you can carry a 10 kilowatt battery in hand. So with the prismatic format, it is more compact. And these are the cells used in your mobile phones and gadgets and all. This is called pouch cells. So look like a pouch. So these are the future form factors. I'll show you some more also. So this is the upcoming cell. This is the actual photo which I have taken in my last visit. So this is 1175 Ah of cell. 3.2 volt, 1175 Ah. This is not available in the market. This I have taken it from a lab in China. So this will be available next year. So one cell on the 1100 Ah, 3.2 volts. Almost. Just calculate how much watt hour it is. Anyone? How to calculate watt hours? 3.7, 3.2 into 1175. That's total power available in the cell. You know power formula, right? V into very easy. Triple. How எல்லாம் சிரிச்சா எப்படி இது முடிஞ்சு இவ்வளவு கொஸ்டின்ஸ் இருக்கு. So how to calculate how many watt hours in this? Answer இதுல இருக்கு. Here 3760 watt hour. There already. There is the thing. So ஒரே ஒரு செல் வந்து 3.7 kilowatt hour. 3.7 kilowatt hour, which means 3 lead acid battery. பெருசு வச்சிருப்பீங்களா வீட்டில் இன்வெர்டர்ஸ் பெரிய பேட்டரி, அந்த 3 batteries ஓட எனர்ஜி இந்த ஒரு செல்ல, which is just the size of your laptop. That is the difference. A சின்ன laptop size battery can have the same amount of energy which is available in the 3 lead acid bigger batteries which is there in your home for UPS home usage. That much of energy can be stored in a very small space. That much of energy density is going to come in future. I'm waiting for this cell to come because we want to use this cell for our BSL. So that I told you in this stage we can put 1 megawatt hour, right? If this cell comes in this same stage, we can put 5 megawatt hour storage in the stage that can power your entire college for 10 days, even a month. So ஒரே ஒரு பேட்டரி வச்சிட்டீங்கன்னா ஒரு மாசம் உங்க காலேஜ்ல இருக்கணும். That much of energy density we have now in the technology. These are actual pictures. And then the other one which is currently used in all the electric cars. So most of us don't know what batteries are used in electric cars. So இதே மாதிரி prismatic cars, cylindrical எது யூஸ் பண்ணாங்க. But for electric cars now there is special cells are made only for electric cars, which is called blade cells. This is also actual photo of Mahindra BE6, the latest car which has come. This is the actual photo of that. I've taken this picture from their factory. So this is the battery which is there in Mahindra BE6. It's called blade cells. Blade cells. Thin prismatic type, but it's a very thin but lengthy one, so that it stays in the car chassis on the bottom. So it won't occupy any space. So complete battery cells are at the bottom of the car. So it also gives the stability for the car. So this is called the blade cell. This is made by only two companies, CATL and BYD. BYD and CATL. These are the two companies which makes these blade cells worldwide. But most of the cars are now switched over to the blade cell. These are about the electric cars. So we talk about the energy. Why electric cars are preferred now? Because whoever has got electric vehicle now, we can have the trend in future is going to be like this. We generate green energy from our rooftop solar. We have a storage of battery, and we have electric vehicle. So we have the complete chain of energy independence and mobility independence. So car petrol போட நம்ம பம்ப் போக மாட்டோம், electricity bill கட்ட போக மாட்டோம், but we can have our own energy, we can drive our car, we can drive our scooter. இதெல்லாம் பாசிபிள் ஆகணும்னா you need to have your own green energy source, which is solar. So you need to generate your energy from solar, and you need to store them for the later usage. Daytime நீங்க டைரக்டா யூஸ் பண்ணிக்கலாம், but evening time யூஸ் பண்றது you need to have storage, then you need to have a EV. Then you are completely independent of your mobility, energy, and energy requirement or electricity requirement. So electric cars, electric vehicles பத்தி யாருக்காவது தெரியுமா? Any idea how electric cars works, electric two-wheeler works? So மொத்தமா simple, I just want to give you a thought. We did some analysis and research பண்ணிருக்கோம். So there are multiple vehicle types: battery electric vehicles, BEV, and called hybrid electric vehicles, and plug-in hybrid electric vehicles, and fuel cell electric vehicles. These are the types of electric vehicles available. We all know this one. This is a complete electric vehicles. This will have only 4 major components. Only 4. What are those 4 major components in the car?
Motor, sir.
Motor.
Control board.
Controller.
Battery.
Battery.
Belter, sir.
Belter. Okay, then the next one is the software system. So majorly only, if you hardware, it's only 3 components. The advantage of electric cars now, the upcoming, I've seen some of the cars, I think most of you would have seen also those cars. I had opportunity to visit the Huawei research center in China recently, just a couple of months ago. So they have launched one new car, Huawei jointly with BYD. New car that has got a crab walk. The car can horizontally move. you can only move straight reverse, right? This can, I've witnessed that you can horizontally move, and horizontally this way, and it can also do a 360-degree turn. நம்ம டாய் கார் எப்படி திருப்புறோமோ அந்த மாதிரி it can do a 360-degree turn, which is already there on the road. It is already there on the road, not in Indian road, but in China it's very much already available. Because how they achieved that is, each wheel has got a individual motors. Every wheel has got a separate motor, separate controller. So 4 wheel இருக்கிற 4 மோட்டரையும் தனித்தனியா they can control. Even drives also separate for that particular motor. Separate drive, separate motor. Only battery source is common. So they can do anything they want with that motor. So frontல இருக்கிற ஒரு wheel மட்டும் அவங்களால ஆபரேட் பண்ண முடியும். ஒரு மோட்டர் மட்டும் ஆபரேட் பண்ண முடியும். பின்னாடி இருக்கிற 4 wheelல வந்து frontல ஒரு wheel, பின்னாடி இருக்கிற அந்த சைடு diagonally ரெண்டுத்தையும் நீங்க ஆபரேட் பண்ணும்போது opposite directionல. This is on clockwise, that is on anti-clockwise. What will happen? The car can turn like this. That is already happening. It's already there in the market, on the road. So many things are possible with electric vehicles. Because we have so much of flexibility in the electric vehicle. Well, in combustion engine, we have centralized engine, then you need a shaft, drives and all. The single engine, you need to transfer the complete motion. But in this, every wheel you can individually control 100%. So that's the future mobility we are talking about. Maybe in a couple of years, we'll be having similar cars. Already BE6 has achieved certain things in India. Mahindra, they have already reached certain amounts, but very soon this will come in India also. So நம்ம கார் வந்து 2 காருக்கு நடுவுல பார்க் பண்றதுக்குலாம் we don't need to போயிட்டு ரிவர்ஸ் எடுத்துலாம் பண்ணதில்லை. ஜஸ்ட் பார்க் பண்ணி ஹரிசாண்டலா மூவ் பண்ணிக்கலாம். முன்னாடி ஒரு காருக்குலாம் பின்னாடி ஒரு காருக்குலாம் நம்ம நடுவில் நிறுத்தி கிராப் மாதிரி சைட்ல மூவ் பண்ணி காரை பார்க் பண்ணி மறுபடியும் கிராப் மாதிரி வெளில எடுக்கும். And you don't need to sit in the seat. You can do this by remote. I mean with your key or mobile app. Whatever Tesla had a feature, these guys are having a much advanced feature in the Huawei car. This is basically the arrangement of electric cars. So what will have only these 3 components will have, nothing else. So this industry, more of electrical and electronics engineers are in demand. Electric car industry is going to boom in India. So anybody who is in that department, please focus on electric car industry. You have a good opportunity. And hybrid cars, you know, there are already hybrid cars available in the market. So, like some brands like Grand Vitara, Toyota Hyryder and all. These cars are hybrid cars. They'll also have a battery and regenerative braking system and power generating system. So when you drive these cars up to 30 km speed, it will work on battery mode. If you cross the 30 km, then it will switch over to the ICE mode. So these are the hybrid engine cars, which is also there. But in future, we may not need that. Once we have 100% electric, we may not need that. So these are some statistics which I don't want to. So let's move on to the energy storage. I'll show you some pictures. This is what I mentioned about 236 gigawatt hour of BESS by 2032. This is a target for India. Indian government has already taken this as a target. 236 gigawatt hour of battery energy storage has to be deployed in India. We have only how many more years? 6 more years. So to be, 6 more years by 230 gigawatt hour. You know the market size of this 236 gigawatt hour? Market size 1 gigawatt hour is 15,000 crore. 1 gigawatt hour BESS business is 15,000 crore. So just think about the market size, it's bigger than automobile industry in India. We are going to have a huge demand of engineers, huge employment opportunity in this industry. But it will just pop up someday within another couple of years, then there will be huge demand. So my advice to all the engineers over here, look at this, monitor this industry, focus on this industry, and this is already one of the fastest growing industry in the world. And India is second fastest growing market in the world. China is number one, and India is second fastest growing market in the world. These are actual data, actually. So these are some actual pictures of best labs I visited recently in Taiwan. This is how they do testing of this battery storage. Each battery is about, all these batteries are 200 kilowatt hour. Each module. All these modules will be connected in series and parallel to get a high voltage. So they connect in series to form 1200 volts. Then they connect a PCS, power conditioning system, we call it, which is nothing but a inverter kind of thing. So that converts the DC into AC, and the AC high voltage, then we step up, then feed into the grid. So that's how the best system works. So basically the cell starts from 3.2 volts, and that will end up in 1200 volts at the battery level. Then at the inverter output level, we will connect it with the 33 kV, 22 or 33 kV line, or even one time. So these are the three. So based on that, we'll use the PCS, power conditioning on it. So this, switching over from that, there are two separate areas in base. One is the DC portion, the other one is the AC portion. So we are talking about the DC portion here. From 3.2 volt cell to, we will make a battery model which delivers 1200 volts DC. Then the 1200 volt DC will be converted as a AC, then stepped up to connect with the 33 kV line or 32 kV line or 110 kV line. So these are the actual pictures I've taken during my vendor visit recently. So these containers, what you are seeing, these are all the energy storage containers. So each container is 6 megawatt hour. Containers. Well, we have a logistics issue in the containers because the actual sea freight containers, 20-foot container or 40-foot container, the payload capacity is only 22 tons and it's fully loaded. So beyond 22 tons, it cannot be lifted because all the cranes and everything across the port, across the world, only with that capacity only. But once we load the battery modules inside these containers, the actual weight of this container is 48 tons. So we cannot lift it with the actual crane which is available in the port. So we need a special lifting equipment to lift these containers. That's why they created a special crane only to lift the energy storage containers. This is a special crane what they created for energy storage application. So now India is deploying a lot of energy storage containers, so they need this crane. So this is specially designed container lifting crane for the bus industry. This is how it is deployed at the site. So each is like 6 megawatt hour. You can see the number of containers deployed. You can see that in Pondicherry also, 6 months from now. Pondicherry is deploying 50 megawatt hour of energy storage. And one of the substations nearby, I think, Korkad, there is a substation coming up, right? Korkad. Korkad is nearby, right? So Korkad, there is going to be energy storage deployment of 50 megawatt hours. So that's all from the battery side. Now we are open for question and answer related to anything. Start from energy production, energy generation, storage and utilization, or anything related to energy. The floor is open for questions. Or green energy or whatever. If you don't ask question, I will be asking question one by one. So shall we start? தம்பி நீங்க சொல்லுங்க லாஸ்ட். Yeah, can you just tell me some of the lithium chemistry which you learned today? I've explained about many chemistries, right? So can you name 2 of the chemistries? The professor in the question class answer. Just name some of the chemistries. The rest of you all just recall. I'm going to ask questions to everyone. Chemistry பார்த்தோம்ல, I explained about multiple types of lithium and chemistry. Just name any 2. The mobile or chemistry use பண்ண சொன்னோம்ல, what is that? சரியா? Conversation கவனிங்க. Okay. Anybody from that last corner? Anybody? Any girls? Girls, கொஞ்சம் focused கவனிப்பீங்கன்னு நினைச்சேன். Anybody from the girls side? No. So just we'll go move on to the conclusion. At least you need some takeaways, right? I'll give you some short answers for you to understand. So there are 3 chemistries commonly used. Lithium NMC. NMC, we call it lithium emitter, as a short form of NMC, lithium manganese cobalt. Then NCA, lithium cobalt aluminum oxide. Then LFP, lithium ferrophosphate, lithium iron phosphate. Then lithium titanate. These are the major chemistries commonly used in most of the energy applications, whether it is gadgets or energy storage or any EV application. Understood? Safe ஞாபகம் வச்சிருக்கீங்களா? திரும்பவும் கேட்பேன். So, can anyone explain what is photovoltaic? EC student இருக்காங்க, is it? EC or triple E? Triple E இருக்காங்களா? யாரெல்லாம் triple E? 1, 2, 3, 4, 5. So triple E இருந்து தமிழ் சொல்லுவோம். What is photovoltaic? படிச்சிருக்கீங்க எந்த செமஸ்டர்ப்பா? எந்த செமஸ்டர்? செகண்ட் இயர், தேர்ட் இயர்? செகண்ட் இயர். அப்போ ஆல்ரெடி படிச்சிருப்பீங்க. What is photovoltaic? சோலார் பேனல் இருக்குல்ல, பார்த்துருக்கியா? அது எப்படி ஒர்க் ஆகுது? What it does? Anyone else? Yes, please.
Sir, photovoltaic are the substance which can convert sunlight into energy using semiconductor.
What type of semiconductor?
It can be silicon, aluminium.
Very good. That's right. So it's a silicon. It converts basically light energy into electrical energy. That is photovoltaic. That is the cheapest form of energy available in the world now. Cheapest form of energy. So every kilowatt hour of energy production will cost you less than 2 rupees when you do it from solar. Just 2 rupees now. Where we pay to the electricity is about 6.75 rupees, right? வீட்டில் யாரெல்லாம் EB bill pay பண்ணிருக்கீங்க? நீங்க யாரும் pay பண்ணிருக்க மாட்டீங்க. Parents தான் pay பண்ணிருக்கோம். But at least you should know how much they are paying. 6.75 rupees per kilowatt hour what we are paying as the average unit cost. Next year it will be 8.75 rupees. The cheapest energy available is solar. 2 rupees is the cost of production. எத்தனை பேர் வீட்ல solar installation இருக்கு? Including professors. எத்தனை பேர் வீட்ல solar install பண்ணிருக்கீங்க? Planning for it. Professors, sir? No. I recommend everyone. You can go back to your parents and you can also say that there is a subsidy available from the government. About 78,000 rupees government is providing you as a subsidy. which will directly hit your accounts. So 78,000 rupees government is providing. The rest you need to spend another 1.5 lakhs rupees to 2 lakhs rupees to have your own solar power plant at your room. Currently, which is available in Pondicherry also. So anybody who want to generate your own power, I very much recommend you to go for it before the Pondicherry Electricity Department privatized. Once that is done, then you cannot get the subsidy. And also you will be having difficulties in getting the net metering. So now is the right time to get into solar on your own solar plant. In the future, நீங்கள் போட்டாலும் உங்களுக்கு net metering connection கிடைக்காது. Maybe கிடைக்கிறதுக்கான வாய்ப்புகள் ரொம்ப கம்மி. So அப்போ வந்து you cannot use it. Now whatever power I am consuming is free of cost for me. So I have a 6 kilowatt of solar power plant in my home, which is installed in 2015, which is almost 10 years now. So out of this 10 years, I am generating close to 36 units energy per day. 36 kilowatt hour energy per day. My actual consumption is 20 to 22 units, even if I use all the ACs even in summer. So I have excess energy of close to 15 units, 15 kilowatt hour per day. So which gives me excess energy of close to 400 plus units, which I am exporting to the EB, for which EB will be paying me after 5.75 rupees per unit. So I will be getting 450 into 5.75 rupees per month from EB from next month onwards. So EB will be paying me 2,500 rupees from next month onwards. Now the system, the scheme has on. They have already collected all our bank accounts and all. So whatever the excess amount will be credited in your account as a money. So far it is only unit to unit adjustment. From this year onwards, it will be paid to you as a cash. End of the year. Whatever the excess unit you are exporting, you will get the payment for it 5.75 rupees. Which means you are generating it for 2 rupees and selling it for 5.75 rupees. You are making 3.75 rupees as a profit. This is called energy trading. There is a new term called in the industry called energy trading. You can buy energy and sell energy. The way you sell the fuel. Petrol station la enna pandranga? What they do in petrol station? They buy petrol or diesel from the Indian Oil or Bharat Petroleum. They add a margin of 1 rupee or 50 paise, whatever it is, they sell it to us. So every liter they sell, they make 1 rupee margin or 50 paise margin. So that is energy trading. Fuel trading is also another form of energy trading. Similar thing is possible from energy also. You can buy electricity and sell electricity with your margin. So if you have your own solar, you are considered as one of the power producer. நம்ம நெய்வேலி பவர் பிளான்ட் மாதிரி நீங்களும் ஒரு பவர் பிளான்ட், பட் சின்ன பவர் பிளான்ட். ஸோ அதில் ப்ரொடியூஸ் ஆகிற எனர்ஜிக்கு கவர்மெண்ட் இஸ் கோயிங் டு பே யூ 5.75 rupees, which means it's a good investment. As an individual பார்த்தா, it's a good investment. You make 2.75 rupees per kilowatt hour margin. Suppose if you are generating 1,000 units, you could able to generate 1,000 units excess from your plant. 27,500 rupees you will be making every month. And yearly it's about close to 3 lakhs rupees. Just by having a solar power plant, you can generate 3 lakh rupees revenue by sitting idle. This is possible now. This is called energy trading. There is another form of energy trading also available, just for you to understand, particularly for the professors. We have another form of energy trading arrangement in India. It's called open access power sales. Suppose I am having a power plant in Pondicherry, but I have a company in Tamil Nadu. Whatever I produce, if I want to sell it to the company in Tamil Nadu, my production, whatever I am producing it from my solar, I can sell it to them. Instead of EB selling power to them, they can buy power from me. For example, you are having a company in Tamil Nadu. நான் பாண்டிச்சேரியில் பவர் பிளான்ட் வச்சிருக்கேன். நீங்கள் தமிழ்நாடு EBல பவர் வாங்குவீங்க, ரைட்டா? ஸோ தமிழ்நாடு EBல வாங்குறதுக்கு பதில் நான் உங்களுக்கு பவர் சேல் பண்ணுவேன். யூ கேன் அவைல் தட். நீங்கள் எனக்கு பே பண்ணுவீங்க, அவ்வளோதான். தமிழ்நாடு வந்து 7 rupees per unit சேல் பண்ணுறாங்க. I will be giving you for 6 rupees. Which means 1 rupee less costing நான் உங்களுக்கு பவர் சேல் பண்ணுவேன், which is allowed. I'm already doing it. Power trading. 2 companies in Tamil Nadu. I'm selling power. Every month, I'm selling them 1.7 lakhs units. Power, I'm selling to one of the company, which is not my business. Personal நான் பண்றேன். You do share trading இல்ல? அந்த மாதிரி I'm doing a power trading. இது உங்களுக்கு தெரியாதுன்றதுனால நான் சொல்றேன். So which is available now. Now personally I'm doing a power trading. Just for you to know, there is a opportunity here. You can buy power and sell it to someone where you make money. Instead of share வாங்கி share விக்கிற மாதிரி, நீங்க fuel வாங்கி fuel விக்கிற மாதிரி, power வாங்கி power விக்கலாம். 1.78 lakh units per month ஒருத்தருக்கு நான் power விக்கிறேன். I buy power for 6.5 rupees க்கு தமிழ்நாட்டுல இருந்து. I sell it to him for 6.75 rupees. I make my trading margin of 25 paise per unit, which means 25 paise per kilowatt hour. So 25 paise into